Welcome to Rocco Radio. I'm Bryan and you're listening to Newsdesk. This week's Newsdesk is focused on IoT security. If you're an MNO, you will know how important it is to ensure security is a key focus for IoT solutions you support. Like ENISA in Europe and NIST in the USA, on the 7th of March, the UK government launched its Secure by Design report, marking a major step forwards for the UK and IoT security. This week we interviewed David Rogers, CEO of Copper Horse, who worked alongside the UK Department of Digital Culture, Media and Sport, the National Cyber Security Centre and ICO to create the Secure by Design report, a code of practice for companies engaging with IoT solutions. David tells us about the background to the code of conduct, the responsibility of all companies to try and advocate strong product security, but also about the impacts on mobile network operators from not having stronger awareness of security across the devices they support with connectivity.
A lot of the connected industry now that's coming together to produce some quite important things that may be connected to people's lives are doing things in such an insecure way that a lot of people in industry believe that governments around the world should regulate on this.
It's a real pleasure to be here with David Rogers, who is the CEO of Copper Horse, which is a company probably many mobile network operators might not have heard of, but is doing some fabulous work right now on, let's say, IoT security. David, welcome to the podcast.
Hi, Jason.
So, David, you've been working quite hard on some important design documents for the British government. Can you tell us a little bit more about the Secure by Design report that you've been working on?
Well, it was a big day yesterday because the culmination of probably about a year's work was launched at a consumer body called Which in the UK. And this really the result of a focus on secure by design by the government. So there's a sort of wider recognition within the UK's industrial strategy and within the cybersecurity strategy of the UK that there is a need to make more secure products to make the UK a safer place to do business in and to live in.
From what I understand, because I did a little bit of research into you before, this is an effort by the Department for Digital Culture, Media and Sport in the UK, by ICO, by the National Cyber Security Centre. So you worked together with those entities to create this code of practice.
Yeah, so DCMS were the lead department on it, and they do a lot of cybersecurity work. But it was really a cross-government collaboration, and also academia were involved, and industry representatives were involved, including from the telecoms industry. It was a really key moment in time, I thought, in terms of the timing, the need for this work to be done, the willingness of the participants to do it, and also the individuals that were involved. It was a really fantastic team, and I think that shows in the sort of resultant output, and we'll still be continuing to do this work throughout this year.
Yeah, you said in your blog, because I read your blog post, security IoT, well, indeed, mobile devices, let's say, is something that we feel fairly secure with. But with IoT security and Internet of Things security, essentially, for people who want to recognize it that way, you felt that you were stepping back 20 years.
Yeah, I truly mean that. My background, I originally came from the semiconductor industry and then came to Panasonic Mobile in 1998. And really the concept of product security didn't exist then. I actually remember searching on LinkedIn for job titles of product security because I thought it sounded weird. There were no job titles for product security, but I went with it and created this role in Panasonic because we needed to concentrate on security at that time. And so then started this whole process of how to secure embedded systems products for telco and how appropriate that is. Now, that's obviously significantly developed since the era of smartphones. And as has the number of attacks and the types of attackers on mobile phones. So what you've got is a very, very mature industry, both on the network side on that and on the handset side, that is well used to being attacked and has built security solutions for that. You've also got a set of attackers who've grown again. Every time we put something in place that secures something, it's a kind of arms race to break that solution. Yeah. So the experience of the attack community has grown massively. So then you kind of set that against the PC industry, which obviously the mobile industry has been able to learn from. They've also increased their security significantly and brought in things like software updates. But suddenly you've got this whole new industry of a lot of startups or a lot of companies that are producing fairly cheap products that haven't really been scrutinized before. And suddenly you realize that all of the learnings that we have in the mobile industry are not being adopted by, say, a webcam manufacturer. And that's very, very frustrating because these products are coming to market and they're being sold and people are being compromised by them. So as I say, that's why I think we step back 20 years, because the solutions are there. They just need to be transferred into that sector or that group of companies that are producing these Internet of Things connected products. Actually, the mobile phone industry as a whole is doing quite a good job on this. That's not really what we're trying to focus on. But if we can transfer that knowledge over to other industries, then we'll win fairly quickly, I think.
No, it's interesting what you say, because I remember working in an operator, and this thing came along called machine to machine, which is now, of course, we know it as Internet of Things. And it was not clear exactly which SIM cards, let's say, were dedicated to Internet of Things devices. And going back, we're talking over 20 years of farming out SIMs in great number ranges, in great quantities, to companies where probably the mobile phone network didn't know what they were going to be used for. And that's kind of interesting because, now we have this scrutiny on it, but in reality, putting a SIM card into a device and putting it into a car or bathroom scales or whatever kind of implementation you make is quite a different thing. And I think that still there is some steps to be taken by operators and any company to try and dig into who is actually using this SIM card, what is it going into, and how is that device potentially hackable.
Yeah, I totally agree with your points. And I think this is an area where I think the operators are concerned. And if they're not, they should be concerned, because people are, say, connecting a GSM module to one of these insecure devices. So you mentioned things like bathroom scales. So the company that produces bathroom scales, traditionally, it has no knowledge of how to connect something to the internet.
Yeah.
The same with these kind of iKettle type solutions where they were hacked fairly early on. These companies just do not have a clue. A washing machine manufacturer doesn't have a clue about security engineering because they've never had to. And a lot of these businesses have been around for many, many years. So, washing machines, maybe 50 years. And this is entirely new for them. But on the one hand, we have to, as a global community, ensure that the products themselves are secure. On the other hand, more advanced industries like the telco industry have to be able to protect their networks from misbehaving devices, whether that be a quality issue, whether that be a security issue. And so obviously in the M2M world, we've had to deal with a lot of fraud of different types, manifesting itself in the same way that previous frauds would have happened, but just using different techniques. It's still the same ways to make money. And so bits around the edges that I agree with you that we need to be able to, for example, identify devices more easily and be able to rely on that identification. So when I speak to some operators, I've had the response, oh, well, we know everything that's on our network because we sell a big bulk deal of SIM cards to, say, DHL or Audi or whatever. But actually, that's not true. Another operator has said to me, no, we're seeing lots and lots and lots of ad hoc IoT where people are taking their own GSM modules and plugging them into strange bits of equipment and then going and sourcing SIM cards from other types of companies, maybe some of these sort of multi-IMSI type SIM companies, and they have no clue what's at the end of it. And this is dangerous because if that operator ever turns off that device for whatever reason, maybe it's generating huge amounts of fraud or something like that, they don't know that that's not physically connected to something that could harm somebody if it's turned off. They don't know if it's maybe something medical related.
Right.
So I've even heard situations about baggage handling systems being very reliant on M2M infrastructure. So this is where the operators start to have quite a lot of increased risk, especially as we have more and more devices that are linked to health or something that could affect safety.
Clearly that it's a totally different ballgame. And I think that's like, we just completed this report and we had a lot of operators give us feedback. But they were aware, they knew that this is, to some extent, is a different game altogether, and they need to take more security in mind. It must be difficult also for operators, let's say, to work with device manufacturers when, literally they don't know what the SIM card is going into, but also when there's a degree of insecurity on the actual device itself. It's like not just the communication channel that needs to be taken care of for the whole solution to work.
Yeah, the threat model has shifted quite considerably. So I think network operators need to be a bit more grown up about managing the device estates and managing what is on the network, because there's a multitude of ways that things can attach to the network too. And also operators are dealing in some cases fixed line. So it could be that a device is tethered to something, and maybe it's a Wi-Fi connection, but the actual data usage is coming through some kind of LTE box or something, which in itself could create issues for the network of outages and so on. It could also be in the case of the fixed line stuff. So there was a big attack called Mirai, which most people have heard about, which I'll talk about a little bit more later on, but a very strongly linked variant of that hit Deutsche Telekom, and it didn't behave as planned, but it still managed to take out a huge number of consumers in Germany. And that's because an operator had a fixed line business too, and that the routers themselves were also insecure products that had things like default passwords and stuff like that. So it's not necessarily just all the stuff that's connected over the telco network. It could be other things that are within the business too.
There's actually, from what you're saying, quite some risk in getting into the IoT business if you're not, prepared from the beginning.
Yeah, so I think that's the message that we want to come from the Secure by Design report. So within that report, we talk about how retailers will look to label products as secure. We have a code of practice, which I wrote in collaboration with those departments in industry. And that code of practice is laying out the basic things that need to be done to secure a product. And if those things aren't in place, then the product, frankly, should not be on sale. Now, it's important to note that we were not a standards body. There are a ton of standards and recommendations bodies out there who are already doing loads of good work in IoT. So GSMA, for example, has a huge amount of security recommendations on IoT, which can be downloaded from their website. It's very, very, very detailed. The IoT Security Foundation as well has a lot of recommendations. There are even recommendations down to city level. So New York City, for example, has security and privacy recommendations for smart cities. So NIST in the US are coming out with their own recommendations, and the NISA in Europe are coming out with their own recommendations. So there are a bunch of things going on, and we know they're already happening. What we focused on with this is that it's outcome-based. So we're saying, what do we actually want to achieve, and what is also measurable and testable? So if a retailer, so a big company, a big retailer like Corte Inglés or Jean Lewis in the UK, how do they help their consumers by stocking products that are secure? And how do they tell their consumers that a product is secure? And so that's where things like consumer bodies like in the UK, which are able potentially to give ratings on the security of a product. So we need to be able to say in our code of practice, well, what outcome can we test? So the top 3 are the main ones we're concentrating on because we think that these will have the biggest impact in the market. So number 1 is the elimination of default passwords. And it may seem, very trivial, but this is the biggest issue that caused Mirai. There were 61 known default username and password combinations. And you can still go and buy lots of products online now that have got default passwords and default usernames of admin. Now, in 2018, that is simply not acceptable. I could have bought products 20 years ago that had the same type of authentication in, but these days, with all the automation of attackers and so on, it's irresponsible to ship a product like that. The second one is about software updates. So again, we all got used to getting software updates and so on devices. A lot of devices may never even get a software update. So you may buy a product from a shop that might be slightly older, but it's gone beyond the point at which the vendor is prepared to provide software updates. Sometimes they're never prepared to provide you with software updates in the first place. And again, these days, that's really, really dangerous because lots of security vulnerabilities could emerge and then be exploited very quickly. So you need to be able to patch devices. So that's another one. And then the other one of the top 3 is something called vulnerability disclosure. And what that is about is a pretty simple measure for vendors to set up a page on their website for security researchers to contact them. So the security researchers on the whole are the good guys, and often they'll be looking at a product and they want to disclose that there's an issue with this product to the vendor. Now, traditionally, it seems crazy, but it's very, very difficult to contact vendors. And what we're saying is there are international standards for this, but if you're producing an IoT product, you need to implement that. You need to be able to have a security email address for your company so that security researchers can disclose vulnerabilities. So you get the message from the good guys before the bad guys start attacking your product. These measures, there's 13 of them. They're very pragmatic. They're reasonably easy to test. And the way I've described them is like a form of insecurity canary. So the analogy is obviously, you took a canary down the coal mine to see if there was gas, and if the canary fell over, then you knew that maybe you should get out of there. And so the insecurity canary in this case is that if you find, for example, default passwords in a product, that is a big warning sign. That says that that vendor, in all likelihood, has not done the more complex things right too. But it's difficult to test that, and it's difficult to inspect that. So, what we're doing is giving the retailers and even consumers the ability to kind of measure that a little bit. And then obviously the retailers can take a decision either to test it further or to potentially say, we're not stocking this product. At the moment, this code of practice is voluntary, but there's a strong indication within the Secure by Design report that this is the first step towards regulation. So basically, we're giving industry a chance to clean house, get its act together, but the UK, along with many other countries, are looking at regulation as an option because, frankly, the government is scared that somebody's going to get killed.
Yeah.
And we can't sit on our hands and do nothing about it.
No, and this also came out in the report we did in Rocco, where there were several MNOs who told us, there's real physical accidents going on. Over 20% of the MNOs were actually aware of physical accidents that had been caused by IoT devices, may not have been within their control to do something, but there was obviously something serious happening. In terms of this report then, for example, you mentioned sometimes for issues like this, we might expect to see some kind of seal of approval. And you mentioned that, potentially businesses can somehow communicate or even market their products through some kind of seal of approval. Is that there yet? Or is that something that
it's
will
outlined in the report, and we talk about a voluntary labelling scheme.
Yeah.
And I think over the next few months, we'll flesh that out a bit more. It's also the way that other countries are looking at this sort of thing as well. So ENISA, for example, have proposed to have some kind of labelling and compliance scheme. So looking at it from the other way, obviously, how does a company say that they are compliant with various measures or with a standard? And you need some way of indicating that. Now, from my personal perspective, I have my own views on this, which is a physical label has its limitations. It's an indicator. But if you think about the way that we buy IoT products now, we buy them online or we go into the shop. We don't actually touch the physical product that we buy until the guy goes and unlocks the case and takes it out and gives it to us. But by then, we've already made the purchase decision. So the value of that physical label on the physical box or on the device itself is diminishing. What I like the idea of is some kind of digital label. And so what I mean by that is using technology like digital certificates that could be issued by a body. And in the mobile industry's case, obviously, we have the GSMA. They, to me, would be an obvious candidate for saying, we'll issue you this digital certificate if you comply with the IoT security guidelines and you can prove it. And so at that point, you have something that's integrity protected from, say, counterfeiters. You also have something that could be used as an anchor so other people could check it and say, oh, yeah, well, the GSMA's backed this. So you can attest to a level of security. And you can also revoke it. So you can withdraw that certification at any point. And again, that could be checked. So it's a smarter way of doing labeling. It's obviously slightly more difficult to implement than a physical label. But then if you think about the consequences for a physical label, it's going to be ripped off immediately by a counterfeiter. So the sort of ongoing joke about the CE mark, for example, which is published and out there, there's drawings on exactly how it should be formed. The joke is that it's not about a European product, that it means China export. So to me, the current labeling system is quite broken. And we have this potential opportunity to create a much better kind of digital labeling system, which would help industry as much as it would help consumers.
Yeah, I guess it's just an understanding of what that might be, because, you picked up on a really good point. Who would be the one to support a labeling solution? Would it be GSMA or another association? Because this is an international thing. From our perspective, what we see, of course, is we work a lot with IoT in the roaming context. So devices are manufactured in Germany, which are going to spend their entire life roaming. Let's say in France, could be a refrigerator, for example. But it could also be something completely different. It could be an industrial IoT item, could be even something used in agriculture. The point is that who should do that? Because essentially it should really be an international label.
Yeah, obviously I mentioned ENISA, but it could be any certifying body, but the concept could be common. Yeah. So as all we're talking about is who do you trust? Who do you trust to say that something is secure and a statement that they tested it or whatever? So there's a lot of testing bodies out there and so on. But what I'm saying is get away from this concept of physical labels and maybe think about the digital end of things and the advantages of doing that. It doesn't matter who the body is. Hopefully, what you can do with things like digital certificates is chain them. So if Bosch manufactured something, for example, then people have a lot of trust in Bosch, but then an organization, say like the GSMA, could sign that digital certificate themselves. And then you have a chain of trust So you might say, well, I don't trust Bosch, but I trust the GSMA, or vice versa.
Yeah.
And then it's down to how you use that, or how, say, a customs authority would use it. So there's multiple ways that it can be done. But all I'm saying is we have this opportunity to be really smart about stuff. And it could even help us when we come to things like identifying devices and identifying, devices that aren't counterfeits on networks. So sort of whitelisting and that kind of thing.
Yeah, for sure. I mean, as well, from your work in the GSMA, there is, of course, some ways of doing this in the mobile world, at least between GSM operators. For fraud purposes, of course, we have multiple variations of fraud in our industry, and certainly in an international context, that is really something that we've never really been able to solve, continues to be growing.
Yeah.
And even with blacklisting of IMEIs or particular IMSIs being blocked or whatever, there is still not a way to master it. And yeah, some people even dedicated their entire careers to trying to solve it. So I can imagine it's down to, like you said, who do you trust? If I think about it in an operator context, or I think about a device with a digital label, there's the software, the hardware, the connectivity. Who's the one to manage that? Who's the one to say, across all these activities, across all these elements, we can say that this device is secure?
Yeah, currently, obviously, in the smartphone world, the Google guys have obviously taken a strong lead on this type of thing. And they have done a lot of work around, for example, streamlining up security updates to consumers. And obviously, there's so many different elements of that chain, from the chipset vendor through to who writes the drivers, through to themselves as operating system vendor, then to the OEM. So yeah, there's this multitude of participants, and then you've got obviously the open source challenge too. So this is where the balance comes in terms of for an industry like IoT, an organization like GSMA could step up to the challenge and say, for anything that's got an embedded SIM in, for example, you have to come through us and we'll certify it. Or ENISA could step up, for example, and say, there's a mandatory EU scheme and we're physically going to do all these things and certify them. But I think what's really going to happen at the end is perhaps a mixture of self-certification and then some validation of the responsible manufacturer of a product. Because these things are so dynamic now, and vulnerabilities are so dynamic, that you can't just say a static thing is secure and it's secure for the rest of its life. But what you can say is, was this product designed in such a way that software updates were taken care of, various security principles were employed during the design, that hardware security was involved in the design. There are certain design approaches you can take, and you can say, yeah, well, you've designed that in a pretty secure way and you haven't done anything irresponsible. Security events do happen, but you have the ability to mitigate those and to deal with them in an acceptable fashion, and you're transparent about the way that you update things and how long you update them for. So then we can make some statements about that. To make a statement about a product and say, this is the most secure thing ever and it's never going to be broken, it's never going to work.
Yeah, never 100% secure. It seems to me like you mentioned, which is a company which most British people will be aware of and giving guidance on which are the best products. But it seems to me that unless we have some kind of digital signature or some kind of overriding association or something which is monitoring this, then we're going to see a lot of different variations. And also, if I think for a moment about the food industry and how they've tried to put regulation in place and how there's so many different variants of it, it's going to be somewhat tough, I think, to really know if a device is secure in the future unless there is some kind of model like you're describing.
Yeah, and obviously the food industry, we all remember the horse meat scandal across Europe. Well, horse meat is less of a scandal in some countries, right? but it would be in the UK. There's no panacea to any of this, right? Because we're up against active adversaries who are always going to try and get around this stuff. So, you look at how counterfeiters get around labels, and they adopt new technology to copy holograms and stuff like that. It is always a continual arms race. But what I find at the moment is a lot of the connected industry now that's coming together to produce some quite important things that may be connected to people's lives are doing things in such an insecure way that a lot of people in industry believe that governments around the world should regulate on this. The next stage is a more complex state, which is how do we maintain that and how do we keep a clean, healthy ecosystem. But if we are to raise the bar significantly and to flush out all of this bad product, then we do have to make a concerted effort to ensure things are securely designed. And hopefully then, the combined efforts of governments, industry, academia, testing organizations will work together to make sure that nobody can put products on the market that, fundamentally, essentially abuse customers. Because that's who's the victim at the end of the day, is an end user.
It seems to me, thinking of an operator perspective for a moment, if I'm an operator with, I don't want to name any names, but you can imagine a big operator brand, even a group brand that is out there, shouldn't I be taking responsibility for where, even beyond what the device manufacturer is doing, shouldn't I be taking responsibility for being a player for connectivity in the solution, to the solution providers, to the vendors of the end, to the retail customer? Shouldn't I be vetting them to some degree, or is that just too much to ask?
I've heard of varying opinions on this. So I've heard some people say, for example, safety is not anything to do with the telecoms providers. It's the person who provides that end application, like a car. That's their responsibility. I've also heard people in the 5G sort of debates about saying, well, with 5G, we can provide network slices that will essentially guarantee network quality to users to the extent that we can guarantee things like safety. So there are different views in this. I think the first view is fundamentally wrong. I think if people think like that, in 5 years' time, they'll probably end up out of a job because there'll have been some kind of death. And I don't say that lightly, but if you think about the issue of network outages and lack of capacity on networks or signaling storms, if it's found that people died as the net result of that, so you could imagine systems where some kind of road infrastructure relies on that network infrastructure. And if people die as a result of that, as a secondary consequence of some network outage, then there will be lawsuits and the operators will be held to account. So I think operators should be taking that seriously and looking at the SLAs that they've got between the various different parties in the value chain, because they often are carrying traffic from devices that they don't have a clue about and have no business association with. But they may have a business association with an MVNO or an MVNE, and their SLAs between them and the ultimate end consumer may be out of step and may not provide the necessary legal guarantors to protect both the consumer and the ultimate network operator.
It's really interesting because in the operator space right now, obviously we've had a number of setbacks. We've had chat apps have come along, which have really challenged the operator's ability to make revenue, because it's essentially devices that use Wi-Fi can also connect to what we call the over-the-top players, where basically revenue is lost. Then there is regulation, especially on the roaming front. I can imagine some big operator groups have thought all about this. They've put a security team in place. They believe that they've sorted out some major security risks. But even those big players, I'm sure in the competition that was going on a few years ago and that is still is going on, where operators are trying to win enterprises to their solution, the speed, the velocity at which this was happening was so great that there can't have been that much focus on security, I don't believe. Because when we talk about IoT security, we're talking about an overall thing which is different from one device to another. So you can't really even talk about IoT security that much without kind of drilling down into the specific security needs. What's the point I'm trying to make? Well, I can imagine the big operators in this space have looked at this at some level, for sure not enough. But the smaller operators who just think, I'm losing revenues here and here, IoT is something I can get involved with, there doesn't seem to be much of a risk, the GSMA is not necessarily pushing me with any regulations that I need to apply to this, I think they're in trouble. And I think they need to look at reports like this and to hear this kind of views, because I think there's some serious work to be done if they want to really strongly get into this market.
I would agree with you. I think at the moment the focus is on the sort of low-hanging fruit, which is a lot of things like insecure webcams have come to light because of issues like Mirai, and people are asking questions going, why the heck is a default password there? And then enterprises are already being targeted with malware that pivots into a network itself. So there's a famous example of the casino fish tank that was hacked into. So definitely that's the first step, is to address those sorts of issues. But then on the network side, so I'll give you an example as well. The Jeep hack a couple of years ago was one of the key points of failure was that the network operator had not configured their services correctly, that allowed the attackers to be able to freely talk to any other device that was sat on that same mobile network. That should never have happened. So when you get fundamental insecurities, both on the network operator side, where they haven't configured things properly, on the air interface side, where things aren't properly done, or on the signaling side, where the things aren't done properly, and then on the device side, you chain all of those things together and you get very frequent plane crashes, right? And, you can use that analogy quite well, because plane usually crashes not because of one thing, but because of a whole sequence of things that all lined up together at the same time. And that's what you see in many, many cyber attacks these days, is that it wasn't the one single thing. It was many different players involved where they all got bits of it wrong. So if we can raise that bar so that each player gets even a little bit better, then we reduce the attack surface massively and ultimately protect consumers.
David, the Secure by Design report, which has just been published the last few days in the UK, is that available freely for anybody to look at?
Yeah, absolutely. So if you just type in DCMS Secure by Design into a search engine, you'll find the report. It's actually open for public review until the 25th of April, in 2018. So I believe anybody can respond to it, and people like myself will be looking at the responses and hopefully making it even better. And throughout the rest of this year, we'll also be looking at sort of the next steps and working with international partners on how to implement this in the best way, and again, how to make the UK particularly one of the most secure places to use Internet of Things products in the world.
Thank you so much for your time. This has really been a pleasure to speak to you. We hope you enjoyed this week's podcast. Look out for more Newsdesks in the coming weeks. Currently, Rocco is working on a new research project with operators on MIoT, mobile IoT. The MIoT strategy report will dig into how MNOs are going to handle this for roaming. Simply go to our research projects page to complete the roaming MIOT survey. Every MNO who takes part will receive an exclusive free executive summary report containing the aggregated data of all MNOs who take part. Until next time, this is Jason Bryan, and you've been listening to Newsdesk from Rocco Radio.